I finally solved one of the biggest issues with OpenClaw, which is agent memory. If any of you used OpenClaw, I'm sure you ran into the issue of one of two things: your agent not remembering things that you've just told it, or two, your conversation seeming to suddenly become lost after only a few messages where the agent doesn't remember what he said to it 5 minutes ago. And that's because its context window is getting full up. So I've created a full system that has completely fixed my agent's memory. He now works perfectly every single time, recalls everything we've talked about, and even auto recalls information without me telling him specifically to do so. And I created a presentation on this that I gave in a webinar the other day, so today we're going to be running through that. So this is how to give your AI agent real memory, not just a bigger context window. Let's start with what the actual problem is and why your agent memory sucks. Number one is that context windows are not a memory. Your model's context window is a scratch pad. It's what holds the information in front of it right now. When the conversation gets too long or all messages get pushed out or when you start a new session, that window is wiped clean. A 200k token context window doesn't mean your agent remembers 200k tokens worth of things. It means it can see 200k tokens at once and only for that conversation. That's a short-term attention span. So how do we fix this? Summaries are not enough. Most people just go for a summarize all messages and inject that summary into the next session. This loses detail. The summaries write once. You aren't always sure your agent's actually going to properly write the summaries. The summaries drift. Summarize the summary enough times and you're playing telephone with your own history. Summaries can't be corrected. If the model hallucinated a fact into a summary, the hallucination is out in its memory. So if you makes up something incorrectly and puts it in there, you can't get rid of it until you actually go in and delete it from the MD file yourself. So some systems try and dump everything into one place. They've got a single vector database or a single memory MD file, right? And the problem with that is that memories have got different lifespans. Information about your task list for the day is not the same as what information about your business or your people that you work with or that kind of long-term sort of memory. There's different retrieval methods. Searching what I did yesterday is not the same as what's our pricing strategy. One big memory block can get bloated and noisy. There can be low quality information in there that your agent now gets confused when it tries to remember certain things. And if one thing goes wrong, the whole system is gone. So manual retrieval is a major bottleneck. That is the biggest issue I ran into, is that if I wanted my agent to remember anything, he had to actively go and search to remember it. So if he didn't decide to search his memory, he would hallucinate and make things up. And this is obviously less than ideal. So we needed an actual automatic recall injection system before every prompt, so the agent would actually have that information on hand and understand the context of what I'm talking about without me explicitly telling it to go and search its memory. There's a few things we actually need memory to do. We need session continuity. The agent should not forget what we discussed 30 minutes ago, even in a long conversation, even if the messages get compacted. It should have cross-session recall. It should remember what I'd said in one session from the 5 days previously versus what I'm talking about in the current session now. It should have durable knowledge. It should be facts that are hard-coded in that it can refer back to and they survive no matter what. They don't get compacted or removed or modified in any way. We need to know what it is that we're trying to work on. We need a record of the things we've done. We need to know what it is that we did today. What have we tried? What have we implemented? What is broken? All those sort of things. It needs automatic recall. It needs to remember this stuff without me specifically telling it to go and research it or remember it. And it needs to make sure that there's a certain level of quality on the memories it's actually saving. So how did I fix this? This is the architecture at a glance. One thing people do a lot is they start stuffing every bit of information they want the agent to know into the memory.md file. And we don't want to do that. That is a very bad idea, because when you do that, it actually is injected at the beginning of every single session. And if that file is very large, then it starts taking up our token context window. So we actually use the memory.md as a very small index. It just points to where information is and it has a map to that information. It also tells us what tools we're using to remember things and how those tools are used. So the layer one of what we have is called lossless claw. This is handling session memory and compaction recovery. So this handles all of our sessions. It saves them over time. It makes a summary from them, and it also can expand the full session when it's needed. OpenStinger is layer two. This is cross-session semantic and temporal recall. This is an actual vector database that is held across all of our sessions. It has every bit of information that we've ever talked about, and it creates durable facts from that information. Then we have a simple para folder, and para is just an organization system of MD files. It's for our durable knowledge, entities, facts, decisions. These are very simple MD files in just a certain folder structure that the agent will follow. Then we have our daily notes, and these are notes the agent takes itself on operational timeline, execution, residue, daily logs, all the things that it notes as it's going along. And then layer 5 is GigaBrain, and this is my favorite one. This is what handles auto recall, capture, deduplication, quality gates, and maintenance. So we're going to explain each of these in detail. Memory MD tells the agent where to look, not what to remember. This is the key part I was just talking about. It doesn't have all of our information in there, it just tells it where to find that information. LCM handles the current conversation. The agent can use LCM grep and LCM expand to drill into compacted history. OpenStinger handles the deep cross-session graph queries via memory search. So this indexes all of our sessions and the key information from it, and our agent can use memory search to find it. Power files are read directly when durable facts are needed. Daily notes are written during execution and read during planning, and GigaBrain sits in the actual OpenClaw memory slot, and this runs before every single prompt. So how does this work? What's it look like in action? Agent receives a question or a task. Before the agent even sees the message, GigaBrain auto-injects relevant context from its registry. Then agent can check the current session using LCM grep and LCM expand. If it doesn't find it, it can do a memory search via OpenStinger for deep graph queries. If the results point to a file, it loads a specific para or daily note via read, and bootstrap file. And the bootstrap files, or agents MD and memory.md, are always in the context, but they're very small, so they're not using up our context token window. So each layer explained, and then how to set it up. Now, instead of actually going into how to set it up, I'm going to give away a free zip file down below that you guys can download that you can give to your OpenClaw and tell it to install, and it will set up your whole memory system for you. So, Session Memory Lossless Claw. LCM Lossless Context Management is a context engine plugin for OpenClaw. It replaces the default legacy context assembly with a system that compacts old messages into structured summaries when the context window fills up. It preserves the full transcript of that session on the disk, so nothing is truly lost, and it lets the agent drill back into compacted history with search and expansion tools. Without it, when your context window fills up, old messages just vanish. With LCM, they're compressed but recoverable. It stores full conversation transcripts, hierarchical summaries following a DAG structure, file snapshots referenced during the conversation, and message metadata and lineage. This solves multiple problems. Long conversations don't lose context. A 4-hour work session doesn't forget hour 1. Compaction is reversible. If a summary dropped to detail, LCM expand can reconstruct it from the source messages. It can search work across the full session. It searches everything, not just what's currently in the context window, and no manual compaction is needed. LCM manages compaction automatically based on context pressure. This is a context engine plugin, and when assigned to OpenClaw, it delegates all context assembly, compaction, and sub-agent context lifecycle to it. It actually replaces OpenClaw's built-in legacy context engine. Now, you can only have one of these active at a time, so LCM replaces it in full. It handles session local memory only. It does not persist anything across sessions. That's what the other layers are for. Layer 2, cross-session recall with OpenStinger. OpenStinger is a bitemporal graph memory system. It stores episodes, entities, and relationships from across all of your agent sessions, and lets you search them semantically, temporally, or by keyword. Think of it as the agent's long-term episodic memory. What did we discuss about pricing last week? OpenStinger query runs. So it uses a vector search to find episodes semantically, and it uses Gemini embeddings to make that vector store. It has graph traversal, so it follows relationships and temporal paths. This means that, like, an idea about what our pricing is linked to a memory about our new offer, which is linked to the information about our company. It has keyword-weighted searches for precise matches, and these are combined into a hybrid search. The bitemporal part means every episode is stored with both creation time and access time. So it gives us a record of when we actually did things and remembered things and chose to put them in the database. So what is Para? This might be something you've heard before already. Para is just a file system setup. Vector databases are great for searching across large amount of information, but when you need the actual full canonical answers, the verified current authoritative fact, you need a file that stores this as a record. So they're inspectable, meaning that anyone can open them, read them, and edit them. They are correctable. You can fix a wrong fact without having to reindex the whole system. They survive tool changes and migrations, and there's no ambiguity about what is stored. It has an atomic fact schema. So this is what the actual information inside the documents look like. It has an ID, it has a fact, it has a category, it has a timestamp and a source, a status, whether it's active or replaced, has how many has been accessed and when it was last accessed. The summary MD is for quick context. The items.json are the source of truth. So things that go in Para are like your business model, pricing, team structure, key decisions and why, people, companies, relationships, preferences that persist across months. What doesn't go in Para is things like we discussed the pricing page today. That goes to daily notes. The bill failed at 3 p.m. Daily notes. Here's the last command output. Session memory. If this fact will matter in 30 days, it goes into Para. If no, daily notes or let it live in the session history. So when there's a conflict between what any other layer recalls and what Para says, Para wins. OpenSinger is a search index, Gigabrain is a recall cache, Para is the canonical record. If you correct a fact in items.json, that correction is immediately authoritative and the other layers will eventually catch up. So what this actually looks like. Para stands for projects, areas, resources, and archives. So you can see you'll have a folder named life. In there, you'll have projects and you'll have like my project, your website project, your new offer project, whatever, which will have a summary and an items.json. Then you'll have areas, people, and in there you have a summary in items.json, and it works that whole way down. That again is the schema and how it's laid out. Now, the cool thing is that facts are never deleted. They just have their status that is superseded instead. So there's one fact per entry. You don't combine pricing 97 and launch March 10th into one fact. And every fact should trace back to where it was learned. These can be... So how does our agent actually get this information? It can be automatically injected using Gigabrain. And Gigabrain indexes this and may inject these relevant facts before the agent even asks, or the agent can directly read them, or it can search and then read. So it can do a memory search and returns a pointer to a Para file and the agent reads a specific file. So layer 4 is our daily operational logs. Why daily notes exist. Daily notes are the operational timeline. They capture what happened in order on a specific day. So you can ask questions like, what did we ship today? When did this error happen? What was the plan this morning? These are the execution log that makes sense of the day without polluting the durable knowledge graph. Things that belong in here are like your heartbeat check results, task completion on blockers, decisions made during execution, errors, investigations, and fixes, all that sort of stuff. How they preserve execution continuity. When a new session starts, agents reads today's daily note to understand what was planned, what's already done, what's blocked, and what happened in the previous sessions today. Gigabrain also indexes daily notes automatically, so relevant entries from recent days surface in auto recall even without the agent explicitly opening the file. Things that shouldn't be in the daily logs are things like routine heartbeat pings, raw command outputs, messages that were just coordination noise. If you're not sure, leave in daily notes. Promote only when the fact is a clear long-term value. So finally, Gigabrain, my favorite part of all of this. Gigabrain solves a major problem, which is that every layer we've built so far, the agent has to decide to search for a memory. LCM needs LCM grep, OpenSinger needs memory search, Para needs read. So that decision point, if you tell your agent to go remember something or to find something you previously talked about, you can't be sure that it has actively gone and used one of those 3 commands to search for it. So Gigabrain removes the need entirely. It's a memory slot plugin for OpenClaw and it runs as a pre-prompt orchestrator. Before the model sees your message, Gigabrain searches its registry for memories relevant to the incoming message, injects matching context into the prompt automatically, captures new memories from the agent's replies when asked, deduplicates against existing memories to prevent bloat, scores the quality with junk filters, plausibility heuristics, and value scoring, and it runs nightly maintenance. It prunes low-value memories, rebuilds entity summaries. The agent doesn't call Gigabrain, Gigabrain calls itself. And it doesn't start from scratch. On first run, it indexes your existing native files and any other markdown files in your workspace. It actually creates an Obsidian vault that you can view and go through at any time in order to get an overview of what memory is being stored. So you can see here, the trigger for Gigabrain is automatic. The trigger for LCM and OpenSinger is manual. Gigabrain uses an SQLite database, LCM uses an LCM database, and OpenSinger uses a Falcor database and Postgres in order to store the information and the memories. Gigabrain is best for what should I know? LCM is best for what did we just say? And OpenSinger is best for what links to what. Gigabrain is a single file structure, whereas LCM is a plugin. So Gigabrain acts as the automatic layer. The others are precision tools. You want both. So how does our agent know how to use these tools? So for the tools our agent actually has to use and call, how does it know when and how to use them? That's what memory MD is for. So your bootstrap files need to stay as small as possible. And bootstrap files are the files that are injected at the beginning of every single session so your agent knows who it is, what it does, its rules and operations, and what you're working on. These are files like agents.md, memory.md, and soul.md, and these are injected into every single model call. It counts against your context window before the conversation even starts. So if you've got a 50,000 character agents.md, that can eat up 12,500 tokens before the agent even says a word to you. In my case, when I looked, I was using nearly 16k tokens at the beginning of every single conversation. So how do we fix this? We turn these into indexes. The bootstrap layer should all be an index, a set of pointers that tell the agent where to find things, not a warehouse of everything it might need. So for example, a memory MD might look something like this. It might have a list of common searches, and might have system notes, and it explains to it what we're using and how it should be using its memory tools. A few search hints, a critical system notes under 500 characters. So how does the system know where to look next? With GigaBrain active, the retrieval chain is automatic. GigaBrain injects relevant context before the agent even thinks about it. Agent reads its memory.md, it sees search patterns, and it knows which tool to use, and then the agent runs the right tool for the right scope. So we have 3 layers of retrieval intelligence, and the agent almost never starts from zero thanks to GigaBrain. So some real examples of the layers working together. If a user sends a message, GigaBrain searches the registry and injects the relevant recall. OpenClaw builds the context, it's bootstrap, GigaBrain recall, and LCM managed history. The model sees a tiny bootstrap and auto recall context, recent messages, and compacted summaries. The model responds, LCM records everything. If context pressure rises, LCM auto compacts. If a user said remember this, GigaBrain captures it. When you need the agent to remember something, agent needs past information. This is auto-injected by GigaBrain. It's already in the context. From this session, LCM grep or LCM expand. From a past session, memory search. If it points to a file, it reads the parent entity or daily note. If it's a durable fact, it's in items.json in our folder structure. So how is new information promoted throughout the system? If new information enters via conversation, you make a decision or tell it to remember something, that is stored in LCM automatically. Operationally relevant today is moved into daily notes. Durably relevant is extracted to para. Users say remember this is captured by GigaBrain. GigaBrain reindexes daily notes on its schedule. OpenSinger indexes sessions on a 10-second poll. So what does happen when your context window actually does fill up, which is still going to happen? The LCM identifies the oldest messages. It creates a structured summary preserving the key facts, decisions, and outcomes. It replaces old messages with a summary in the active context, and a full transcript is preserved on disk, and the agent can drill back the LCM expand if needed. So an example of an end-to-end lifecycle of a fact. Lucas says, our pricing is $297. LCM stores it in a conversation transcript. If compacted, preserved in the summary. The agent logs pricing confirmed $297 in its memory file. GigaBrain captures if Lucas says remember the pricing, and it's stored with a confidence score. And then atomic facts are extracted to the project that is involved relating to our pricing in the items.json. OpenSinger then indexes the session, and future graph queries will return that episode. And on a new session, GigaBrain auto-injects pricing context, no manual search is needed. That one fact flows through 5 layers, each one did one job, and the agent never has to even think about where it lives. So this is how your agent will basically decide how it should use each of these tools. When to use each tool. Situation. Most questions about past context. GigaBrain has auto-recalled it. It's already injected. 0 effort. What did we discuss earlier in this chat? LCM grep or LCM expand are used. Deep cross-session graph queries. Memory search is used. What's our business model? It reads the information in the summary.md. What did I ship yesterday? The daily notes are read. Where do I find info about X? Is in the memory.md search hints. It'll be able to find where that information is stored. So in the decision tree, if we need information, did GigaBrain already inject it? Yes, use it, done. From this conversation, yes, LCM grep, LCM expand. From a past session, yes, memory search uses OpenStinger. Is it a durable canonical fact? Yes, read from the life folder. What happened on a specific day? Yes, read memory, year, month, date. Not sure where it is. GigaBrain probably already injected something. If not, memory search and let the results guide you. That is the rule for our agent to follow. So why is this stack designed the way it is? It's a file first stack. If it matters, it's a file. Files survive everything. Model changes, tool changes, database migration, service outages, vector databases come and go. Markdown files are forever, as long as you don't delete your entire OpenClaw setup, which I have done. Retrieval first. Don't preload, don't stuff the context window. Pull what you need when you need it. 3 targeted reads beat 1 massive prompt injection. It's automatic over manual. The best retrieval is the one that happens with the agent deciding to do it. So that's why GigaBrain's pre-prompt injection means the agent can start every turn with relevant context. It doesn't have to decide to run a memory search, although it can if it needs to using the other tools. Every token in your bootstrap file is a tax on every model call. Keep it under 2,500 tokens total. Index, don't warehouse. Also, we supersede, we don't delete. We never destroy a fact, just mark it as superseded and add the new version. History has value because it can help us determine why we made decisions we did, or what broke, or things, or what updated our system and made it better, things like that. Specialized layers beat monoliths. Session memory, cross-session recall, durable knowledge, operational logs, automatic recall are 5 different problems. They need 5 different solutions. And it's inspectable. Every layer in this stack is a file, a database I can query, or a service I can health check. The Obsidian Vault makes even the magical auto recall layer visible. There is no black box. Now, these are the mistakes that I've made throughout my time with OpenClaw, right? Treating summaries as memory. LCM summaries are compression artifacts. They're useful for context management. They are not your long-term memory. If you need a fact to survive a session reset, it must be in Para, GigaBrain, or OpenStinger. Not separating local and durable memory. Session memory and durable memory serve different purposes. Mixing them means your agent either forgets too fast or it bloats too much. Storing too much in the bootstrap is the one most people do. We've seen agents MD files grow way above 50k characters, and at that point, you've eaten up half your context window before you've even said hello in the conversation. And one extremely common one is actually to install a memory plugin, but not actually set it as the active memory plugin in the OpenClaw config. Another one is forgetting to restart after the config changes and wondering why your agent's not using its new tools. You should restart the gateway, and I would also suggest starting a new session. You also shouldn't rely on daily notes to be your durable memory. If it's a fact that matters for today, that's fine, but if it's a fact that's going to matter in 30 days, that should be promoted to our Para system. Another one I've seen is people setting it up, thinking they've got everything going and just trusting it's working without actually checking. The trick I have for this is to go to your agent and do /verbose, VERBOSE, space on. Then ask it to remember something. See if it's actually using LCM grep or memory search or any of the other commands in order to actually search its memory. You can't just rely on your OpenClaw to actually use the tools you've given it. Sometimes it lies. And don't rely on manual search alone. That's why GigaBrain is so important. It automatically gives the agent context and information and memory so that it doesn't always have to do a memory search or an LCM grep in order to understand what's happening. So why is this better than the typical memory that is shipped with OpenClaw or a tool like SuperMemory? Well, it's modular. Each layer is independent. You can run any one of these on their own. You could just set up the Para structure without OpenStinger. You can run LCM without GigaBrain. You can add or remove layers without breaking the others. We have 2 modes. We have automatic and precise. So GigaBrain can handle the 80% case, which is auto-injecting relevant context before each prompt. LCM, OpenStinger, and Para handle the other 20%, which are targeted precision queries. So you get both convenience and control. It's inspectable, and this is a big part of an issue with OpenClaw, is the observability around OpenClaw. With our system, every piece of memory is a file you can read or a database you can query. There is no information being stored that you can't get access to. Nothing leaves your infrastructure as well. There's no cloud memory services. You don't have to pay for any of this. It's all totally free. So you're not paying something like SuperMemory 20 to 200 bucks a month just to store your agent's memory. You can use any model you want and any setup you want with this. It'll always still all be there. You could delete your OpenClaw setup and still have those memories there saved. And it's self-maintaining. GigaBrain runs nightly maintenance. It deduplicates, does quality scoring, prunes low-value memories. So the system actually gets cleaner over time, and your agent gets better at remembering and smarter, rather than getting more confused as files bloat up and it has old memories stored alongside brand new ones. So what are key takeaways from this? Context windows are not memory. Summaries are not memory. One big blob is not memory, and manual search alone is not a reliable memory. Memory is a system. It's layered, specialized, inspectable, automatic, and durable. You've got to build it right, and your agents don't just respond to what's in front of it. It knows things across sessions, across days, across months without being asked to look. So because I am so happy that the system is working, my agent remembers pretty much everything that I ask it to. It don't have to do any maintenance on it anymore. After many, many times I have my agent forget what we just talked about, or have no recollection of what it did overnight while it was working. This has now completely solved all of those issues for me. So I'm actually going to be giving away a zip file that contains the install instructions for your agent to set it up in the description below. This is what's inside that zip file. It's very small. It's just prompts for your agent to use in order to set up this system itself. So it's got an install prompt for the agent to use. It's got a manifest. It's got a README that you can read yourself as well. It's got some docs around research notes and the first version spec. It's got some examples in here of config snippets. It's got some scripts just to help apply all of this stuff and package it. And it's got some templates for the files for your agents MD, memory MD, para MD, and your workspace memory system, and some patches that can be applied to your existing setup as well. All you got to do is drag this zip file here into your OpenClaw agent. Tell it that you want it to review this first. If you want to say to it, review it, don't install anything. Tell me how we're going to set it up, and then it will go through and set up the whole thing for you. So click below to get access to that, and I'll see you guys in the next one. Peace.